Hi, welcome to Notes 152, Lesson 10.3. Today we're going to use inverses, which we learned in the last video, to solve systems of equations. So remember yesterday we talked about A, B, C, D, matrix A, B, C, D. Notice I used an uppercase letter to represent the matrix and lower cases to represent the entries. So we said A inverse, the inverse, is equal to, if I cross multiply, A times D minus, and then I'm cross multiply CB. We call this the determinant. And then I'm going to take the entries. I'm going to switch them around a little bit. A and D switch spots. So D and A become here. And then I've got minus B and minus C in those spots. Okay, so remember this from yesterday. It's going to become really important today. Okay, so what we've got is we're gonna work on page 766, number 52. Okay, and they're going to give us a system of equations. So they've got 18x plus 12y is equal to 13. And then the second equation is 30x plus 24y is equal to 23. All right, so there we have it. So the first thing I'm going to go ahead and do is I'm going to turn this into a system of matrices. Notice that my x's are lined up, my y's are lined up, and my answers are lined up. So this is going to be 18 and 30. 12 and 24. I've got my variables. That would be x and y. And then my answers over here, I've got 13 and 23. Okay, so think about this. If this is A, right, this is X, matrix X, and then this is matrix B. So what I have over here, if I have matrix A times matrix X is equal to matrix B, which is exactly what I have. A, let me get a pen. I got matrix A here, I have matrix X here, and I have matrix B. So A times X is equal to matrix B. And then if I can go ahead and think about it, I've got, if I solve that equation, I'm really not dividing because you don't divide matrices, you use the inverse. So I can say that X is equal to A inverse times matrix B. Okay, so let's go ahead and set this up. So I've got A inverse, which would be 1 over, let's see, the inverse here. So I've got to find the determinant. So I'm going to do 18 times 24 minus 30 times 12. And then I'm going to take the adjoint. So I'm going to switch the spots of 18 and 24. So the 24 is going up here, and the 18 is going down here. And I'm going to make this negative 30, and I'm making this negative 12. Okay. And then I'm going to multiply time by matrix B, which is right here, which is 13 and 23. Okay. So what you want to do here, and I got to be totally honest with you, I would go ahead and multiply these two together first. When you multiply, notice that you've got, for size-wise, this is going to be a 2 by 2 matrix, and this is a 2 by 1. So your 2's on the inside are the same, but your answers are going to be, your answer is going to be a 2 by 1. So you'll multiply, so you do 24 times 13 plus negative 12 plus 23, and save everybody some time. That's going to be 36. And then negative 30 times 13 plus 18 times 23, that's going to be 24. Okay, so we've got 36 and 24. And over here I do my calculations, and I have 1 over 72. All right, so my last step is now to do my scalar multiplication. Let's go back and think about what matrix X equals. The matrix X is equal to XY, right? This matrix. So if I go ahead and I do my scalar multiplication, that's 36 over 72. And then I've got 24 over 72, right? Quick little divisions. This is beautiful. I've got half, 1/2, and I've got 24 over 72, which is 1/3. So you see what we just did? We just solved that. We said matrix XY is equal to 1/2, 1/3. So X is equal to 1/2, and Y is equal to 1/3. Okay, that's just beautiful, absolutely beautiful. I want to talk about the determinants since we're here, and the determinant of a 1 by 1, a determinant of a 2 by 2. We found that determinant right here, right? You know that this is the determinant. this determinant, it's a 2 by 2, right? And so you're probably thinking to yourself, why is the determinant important? Well, the determinant is really important because if this value is 0, I'm not going to bother finding the inverse, all right? And it's a lot of work. I showed you that the other day. Doing it by hand, it's a lot of work. If you're using your 84, it's going to give you an error. So determinants are important. And you just want to find out if a matrix is invertible or not. But if you want to find the determinant of a 3 by 3, all right, 3 by 3 matrix. Now, look, I got to tell you, I do this totally different than Ron does in the book. Ron uses the cofactor method, and I think a 3 by 3 matrix is just easier to do. Let me give you an example with a basket weaving method. So stay with me on this one. So here's my matrix. I'm going to call it matrix A. Again, I got to come up with a better letter for that. 0, 2, 1, 3, negative 1, 2, 4, 0, 1. All right, so here's my matrix. All right, so what I'm going to do is I'm going to do, just like up here with a 2 by 2, I crisscross and I subtracted. All right, so I'm going to write my matrix exactly like I have here. I'm going to leave the brackets out. So I have 0, 3, 4. Be really neat. You guys that are messy like me, we have to really work hard at this. We have to be really neat at this. So what we're going to do, if I go ahead and I did a multiplication here, I would get all of these numbers, but I would leave these numbers out and I would leave those numbers out. So what I'm going to do is I'm going to take these first two rows, first two columns, and I'm going to rewrite them right next to it. Exact order, I'm just going to rewrite them. So this first column, 0, 3, 4 goes here, and the second column, 2, negative 1, 0 goes there. All right, I'm just going to do it. So what you're going to end up doing to find the determinant, make sure this is on my paper. There it is. Okay, I'm going to scroll it down a little bit for you. I'm going to go ahead and I'm going to do the same thing I did with a 2 by 2. Okay? But what I have here is I'm going to multiply. I'm going to multiply 0 times negative 1 times 1. That's going to give me 0. I'm going to go ahead and multiply straight down here. I'm going to multiply 2 times 2 times 4, which is going to give me 16. I'm going to add them together. And then I'm going to multiply 1 times 3 times 0, which is 0. Okay? So I've got 0, 16, and 2. And just like with my 2 by 2, I went the other direction. I'm going to multiply this way, straight across. Look at that. It's called the basket weaving method. 4 times negative 1 times 1 is negative 4. I've got 0 times 2 times 0, which is 0. And I've got 1 times 3 times 2, which is 6. All right? So my job now is just to simplify. So my determinant here is going to be 16 minus 2, which is going to be 14. All right? So if I know that my matrix has this, my 3 by 3 matrix has a determinant of 14, then I know, yes, it has an inverse, which is important. All right, so I can tell if my matrix has an inverse by using, finding the determinant. Again, the book is going to use a completely different method, and that's fine. Feel free to read the book and try out what Ron's got to do. But I have to tell you, I'm really a messy person and I lose signs. So for me, the basket weaving method was simpler. Again, I just rewrote the whole thing here. I wrote the whole matrix right here. And then I rewrote the first two columns alongside. I multiplied down, added them together. I went the other direction here, added them together, and subtracted. And I found out the determinant here was 14, so I know it has an inverse. Okay? Have fun.